Moving between the Lambda console and local development environments can disrupt your workflow and require manual setup steps. You can now transition from the Lambda console directly to Kiro or Cursor IDEs with a single click. You can open Lambda functions in your preferred IDE while preserving your existing code and configurations. You can convert your applications to AWS SaaS templates within these IDEs to enable infrastructure as code practices and C/CD pipeline integration. You can initiate this workflow from the Code tab in the Lambda console or during function creation. This integration is available in all commercial AWS regions at no additional cost. Previously, accessing data from S3 backups required initiating a full restore operation, which was time-consuming and inefficient when you only needed to verify specific files, perform compliance audits, or conduct forensic investigations. AWS Backup for S3 now addresses this by enabling direct read-only access to backup data without restoration. You can create S3 access points for your recovery points and immediately read backup data using standard S3 operations like getObject, headObject, and listObjects ev2. This works with both snapshot and continuous point-in-time recovery points stored in standard or logically air-gapped vaults, including those shared across accounts through AWS Resource Access Manager or multi-party approval. While an access point is active, the associated recovery point is protected from deletion, ensuring data integrity during your operations. You can create access points through the AWS Backup Console, API, or CLI in select regions. Running containers that need GPU acceleration often requires provisioning full GPU instances, even when your workload only uses a fraction of the available GPU resources. This leads to over-provisioning and increased infrastructure costs for workloads like small model AI inference, model experimentation, and graphics rendering. You can now request fractional GPUs by setting GPU equals 0.125, GPU equals 0.25, or GPU equals 0.5 in your ECS task definition container configuration. ECS automatically places your task on a G6F instance with an NVIDIA L4 Tensor Core GPU that satisfies your request, allowing you to right-size your containers and reduce costs. You can use ECS managed instances to get instance provisioning, scaling, patching, and lifecycle management handled automatically, letting you focus on your workloads rather than infrastructure. ECS also provides GPU metrics through CloudWatch Container Insights and automatic health monitoring that detects GPU hardware failures and replaces unhealthy instances to minimize disruption. This capability is available in all AWS regions where EC2 G6F instances are available. Running AI agents at scale presents challenges when you need sustained workloads, resource-intensive operations, or specialized hardware beyond what serverless options provide. Runtime instances in Amazon Bedrock AgentCore address this by letting you run agents on EC2 instances while AgentCore handles provisioning, patching, scaling, and lifecycle management. You can run agents on EC2 without managing infrastructure, selecting from the full range of instance types to match your requirements. You choose GPU, memory, or compute-optimized instances based on your agent's needs, giving you access to specialized hardware for demanding workloads. You support agent sessions up to 14 days, compared to 8 hours with the default microvm-based runtime, enabling long-running operations. You create capacity providers via console, CLI, or API by specifying the EC2 instance types you need and attaching your agents to them. This approach lets you select the right compute for each agent or run a mix of runtime types without changing how you deploy or invoke agents. Runtime instances are available in 9 AWS regions with charges for compute management in addition to EC2 costs.